So good morning everyone. So look over here. So in the previous class we have completed in 5 classes of the matrices and determinant. We have completed all varieties of the questions. Clear? So today we are doing the top 10 PIQs, the main concepts of the PI, the top 10 PIQ of algebra. Clear? So the main reason behind selecting this type of question is that so whenever we have a different varieties of the questions, clear? Different varieties of the question, how can we deal with that one? Clear? So especially the MCQ one and the conceptual question. Clear? So look over here. So here there is a question, as we have already done the skew symmetric and the symmetric question. Clear? So given a skew symmetric matrix A equals to this, find the values of this. So I have already told you that in a skew symmetric matrix, if you select any skew symmetric matrix, that diagonal element is always 0. Yes or no? Clear? That diagonal element is always 0, and its opposite element is, opposite means this element. Suppose this is A, this is minus A. This walk like a mirror. Clear? If this is B, this is minus B. If you write this is C, then this is minus C. So that is for the skew symmetric matrix. Whereas for the symmetric matrix, if the diagonal element can be any element, opposite element are what? Same. So this walk like a mirror. So similarly, then we can say that in this question, so diagonal element, that is B, should be 0. Clear? B should be 0. Then opposite element should be what? Equal and opposite. If this is minus 1, then A must be 1. Clear? Similarly, if this is C, if this is 1, then C must be minus 1. C must be minus. Am I clear? Whereas for the symmetric, diagonal element should be same. For example, if this is minus 1, this is also minus 1. Clear? That category. But diagonal element can be any element. So this is the values of A, B, C. Now you just put over here. So A is 1, a B is 0, and the C is minus 1. So altogether you are getting a 0 square. So that is 0. Clear? So 1 minus 1 is 0. So you are getting 0 as answer. So this is how we'll do this question. Clear? This is a past year 2020 question. So can we proceed to next question? Clear? So diagonal element works like a mirror. Opposite element is what? Equal and opposite. That is the concepts of the skew symmetric matrix. So here, if A is a written as P plus Q, where P is symmetric matrix and Q is skew symmetric matrix, you know we have done one theorem that any square matrix can be expressed as a sum of the symmetric and skew symmetric matrix. In that cases, you know very well, if A is a matrix, then we'll express this as a, in our regular class we have already completed this one. So half into A plus A transpose plus half into A minus A transpose. You know very well this one. So expressing the matrix as the sum of the symmetric and skew symmetric. And this is actually what? P. And this is actually Q. Because you know that this is symmetric and this is skew symmetric. Here also they have denoted the same. If A, this is a square matrix, is written as P plus Q, where P is a symmetric, that means look over here. Sometime they might give you P and Q instead of P and Q. They might give you other value. For example, X plus Y. Clear? Then X is this, Y is this. Because X means symmetric, whatever that is, this is a symmetric. So you have to find out the P matrix. So you know very well, whenever this type of question comes, suppose A is here 3, 5, 7, 9. So you have to find out A transpose first. So what is the A transpose? 3, 7, 5, 9. So P means what? P means half into A plus A transpose. So you have to find out this. Clear? Because then write the matrix P. So half A plus A transpose. Just add this one. So I have given you one more shortcut. You know very well. So in symmetric matrix, in this matrix, the diagonal you have to make A double. So what is the A? 3 and 9 double is 3 is 6. 9 double is here 18. Here, or you can add this one because these are 2 into 2, you can add in this way. But whenever 3 into 3, you know I have given you the tricks that the make diagonal element. For this case, diagonal element double, and just find upper 3 element only, and the rest the opposite is same. So look at 5 plus 7 is 12. So in symmetric we know that if this is 12, this must be 12. You can check this one. 7 plus 5 is 12. But now we have to divide by 2. So if everything divided by 2, so it becomes 3. It becomes 6, it becomes 6 and 9. So this is your symmetry. Clear? So look, if suppose extra, okay, if suppose they want to find out the Q, since I have already told you that Q is a skew symmetric matrix. This is skew symmetry, and skew symmetric matrix, just now I have told you that diagonal is 0 without thinking any diagonal. So now 5 minus 7 is minus 2. If this is minus 2, this is 2. That's it. So then your answer will be 0, -1, 1 and 0. Am I clear? If they will say that, find a q also, then also it is easy. Because in skew symmetric matrix, because this is skew symmetric, make diagonal 0, just find this one element only, whatever be the element, that opposite element is equal and opposite. Whereas in symmetric, I'll just finding this element only. 5 plus 7 is 12. If this 12, this must be 12, because diagonal element walk like a mirror. Is this very helpful? Because it is a 2 into 2, they might give you 3 into 3 also. Clear? Main part is this, because we have already done one sum, that is express any matrix, or we can express any matrix, any square matrix, as a sum of the symmetric and skew symmetric. The next question. So look, this is also interesting question. Clear? So look over. If AB equals to A and BA equals to, so look over. AB is given as a and BA is given as a B. So can we write in this way? So AB. Listen carefully. B. So if we put this B values over here, so we can write BA is equals to A. Can we write this? Check it. Am I clear? I am putting this B values, this B as a BA over here. Clear? So you know there is a one property that this, clear, associative property is that ABC is same as a ABC. So you can multiply last two, but you cannot interchange the position. Remember that AB is not equals to BA, but you can perform first last two, then perform with the first. You can interchange the position. Clear? BA, sorry. Clear? So look over it. That means here you see that. So then we can write AB, A is equals to A. So again, in place of AB, I can write A. So A into A is equals to A. So you are getting A square is equals to A. So this is the relation. Clear? So this is the correct relation. So but, or you can write in this way. Let's find, can we get any more relation? Suppose this is a BA is equals to B. So can we write B as a, in place of A, I'm putting in these values. So then it is AB is equals to B. Am I clear? So we can write this as a BA into B. Clear? Associative law. I'm using this law. So BA is again B. So B into B is equals to B. So you are getting actually what? Either these two both are the correct. So A square equals to A is also correct. B square equals to B is also correct. But here B square is equals to A1 as a A. So this is wrong. So this is the only option that actually both are the correct answer. Remember that this is also correct. This is also correct. Since in the MCQ both option is not there, only one option is there. So this answer is correct. Any doubt? Clear? So next. DAIG means diagonal matrix. It is called diagonal matrix. I hope you all know the diagonal matrix. So look over here. In diagonal matrix, you know very well. This is the diagonal matrix. Suppose A, B, C, everything is 0. Diagonal matrix are that square matrix where each and every elements are what? 0 except in the diagonal. Suppose another matrix is there. Suppose 2, 0, 0, 3, 1, 4. Sorry. This 3, this 4, this 0, 0, 0. So if you see, when you perform diagonal matrix plus minus another diagonal matrix, you see very well, you will get a diagonal matrix. Yes or no? Why? Because when you add this one, this element 0 plus 0 will become same. So that's why this element will only add. So this type of question can be done in this way. Look over. So that means 3a minus 2b is equals to, what is a 3a? 3a means you have to multiply all elements. Since all element means all are 0 only. If you multiply any number with the 0, it gives you 0. So diagonal element, if I multiply with 3, so this become what? This matrix become what? Diagonal matrix of 3 into 5 is 15. Clear? So actually you can do directly. I'll give you the shortcut as well. 15, 3 into minus 2 is 6, 3 into 7 is 21. Minus. Now I am multiplying with 2. 2 into b is diagonal of, this is a diagonal matrix. 2 into 7 is 14, 2 into 8 is 16, 2 into 5 is 10. So now just subtract. 15 minus 14 is 1. minus 6 minus 16 is minus 22. 21 minus 10 is 11. So that is the answer, diagonal of answer. So 1 minus diagonal of this. So look at this question. Actually, this is a lengthy process. So this question can be dealt in this way. So these are what? Thrice of a. So just multiply 3 into 5. 3 into 5 is 15. And then multiply b with 2 into 7. So 2 into 7 is 14. So 15 minus 14 is 1. Clear? So this option is wrong. Why? Because we are going through the option test. Because in this question, the first element is minus 1. That's why it is wrong. Clear? So better let's not waste our time, because we have now left with a and b only, where middle element is minus 22. Here also, here too. So I'll check with the third element only. So 3 into 7 is 21. 2 into 5 is, clear? Look out. 3 into 7 is 21. Clear? And then 2 into 5 is 10. So 21 minus 10 is 11. So this is the correct option. So in this way, actually, we have to deal in MCQ. It is not that the process is required. So main part, how to deal. The concept is very important. So first, what I have done, I have just finding the first element. So first element I have find 1. Yes or no? 3 into 15 and 2 into 7, 14, 1. So in these two options, B and C, you have an option minus 1. That's why I'm neglecting this one. So either now we are in 50-50, A and D. So in A and D, we see that the middle element is here also minus 22, here also. So I'm not checking middle element. The middle element is obviously minus 22. So I'm checking the third element. Clear? So next. Here, a very important note. Now listen carefully, okay? The sum of the product of the element of a row or the column with their corresponding cofactor is actually the determinant. As we know, listen carefully, okay? So you know, if I write 3 into 3 matrix, everyone listen carefully, okay? A11, A12, A13, A21, A22, A23, A31, A32, and A33. You know how we'll find out the determinant? Suppose this is A. How will find determinant? We'll choose any one row. For example, if we choose A11, if we choose this first row A11. So what we'll do? So you'll hide the row and column of this one. So that means hiding the row and column, as we know very well, plus minus plus. Hiding the row and column means you are taking actually cofactor. Yes or no? Actually it is minor, but with the proper sign it is cofactor. So you are writing, hiding this means you are writing the cofactor of A11. Again look, when I write A12, so then again you will hide this one. So hiding this means you are writing cofactor. So again here is y plus A12 plus A13, A13. So this is actually the determinant. If you think that, sir, actually in our determinant this is minus. Yes, dear, it is minus. Clear? Why? Because when you find a cofactor of this, so first we'll hide this one. So then we know that we have to put the proper sign as a minus. So here you have to put a minus. Am I clear? So actually that means, remember that what is actually the determinant value, how to expand. So you have to take any one row or the column. So you have to multiply by its cofactor with same cofactor. Remember that. That means if you remember this one, so look over, they are selecting this one. So A11 cofactor of A11. A12 cofactor of A12. A13. So cofactor is sometimes denoted by C, sometimes denoted by capital A. Any doubt? Clear? But the important part is that the second part. But if you take any one row or the column and taking the multiply with the other row or the column cofactor, then the determinant value is 0. Check it. If the element of the row or the column are multiplied with cofactor of any other row or column, then their sum is 0. That means look over. This is which row? This is which row? This is first row. Clear? This is row 1. Clear? This is which row? Cofactor. 2 1. 2 1 means this one. This is the row 2. So that means if we multiply the same element, any element we take, if we multiply by it with that element cofactor only, with the same row cofactor only, then it is the determinant value. Otherwise, the value is 0. Very important part. Am I clear? Not only this, if we take this row, for example, this row, third row. So that means look over. What is the determinant value? You can write this also. A21 capital A21, A22 capital A22 plus A23 capital A23. This is also determinant value. Now here I am selecting second row, but if you see here, so I am selecting second row, I am taking the cofactor of second row as well. Take it. So then it is a determinant value. Similarly, if you try to take the third row, for example, or this one, let's we consider this one, okay, column. So if you want to consider A13, clear, then you have to consider A13 plus A23, A23, A33, A33. This is very important. Am I clear? So you can take any one row and any column, that is the values of determinant. But make sure that, now how to check, if we see this one, the determinant values is, this both should be same. Check it. Every element should be same. So there is a one NCRT question in MCQ also. Please check that one. Okay? It is dependent upon this. But if we multiply with, if we take this row element, but taking the cofactor of the other row, then the values is 0. Any doubt? Clear? So look over it. Check it. This question. Read it. Given that Aij is a square matrix of order 3 into 3, where determinant is given as a -7, then the values of this, where Aij denotes cofactor. So look over. You have to find out the values of summation of I equals to 1 to 3, AI2, capital AI2. Listen carefully. So summation, I hope you all know, summation means we'll put the values from 1 to 3 and then add. So you are getting A12, A12 plus another one. Now I am putting in place of I2, A22, capital of A22 plus A32, capital of A32. Any doubt? Clear? So let's check, okay, what value, whether it is 0, clear, or the same determinant value. So look over it. So can we write this one? A11, A12, A22. Clear? A121. Just wait, just wait. So look, A12, this is a A12, A13. These are A21, A22, A23. Check it which row they are, which row or column they are taking. This A23. So A32, A33. Check it which row they are taking. 1, 2. Clear? 1, 2, 2, 2, 3, 2. That means they are taking this. And multiplying by same, yes or no? So whenever they are multiplying with the same, look over it. These are same. So it implies that what? It implies that determinant of A. So determinant of A is here given as a -7. Any doubt? Goda, any doubt? That means whenever, here, whenever they are multiplying, they can select any one row or any one column. But remember that if they will multiply that row or the column by the same cofactor, then that same row cofactor, then the values is determinant. Otherwise, it is 0. Clear? So let's proceed to next. So that means this answer is, what is the best approach of this question? If better than this, clear? If this is the question, okay, let's do the next one. Check it here. Here, given that A, same question, totally value same, but here look over here. So A1211, capital A21, A12, capital A21 plus A13, capital A23. You see that this is not the same. So they are multiplying different rows or the column cofactor. So answer is definitely what? 0. Yeah, actually the option is same, okay, same as previous one. I have not typed this one. So answer is 0. Am I clear? Same as this option, okay. This is also MCQ question. This same as this C option. Am I clear? Why? Because you see that this, and this is of which row? 1, 1, 1, 2, 1, 3 is a row 1. Whereas if we consider this, and this is, they are considering row 2. So that means the element is multiplied by other rows cofactors, then the values is 0. So next question, an interesting one. So if A is a square matrix of order 3 and A dash means transpose of A equals to 3, then determinant of A n. So you know one property I have given, that the determinant of A transpose clear is same as a determinant of A. A transpose is denoted by dash also, it is same only. Clear? And another property I have given you, so that determinant of AB is same as a what? Determinant of A, determinant of B. Clear? So look over. So we have to find out the determinant of A and A transpose. Isn't it this is determinant of A into determinant of A transpose? As I have already told you, determinant of A transpose is minus 3. So this is also minus 3, dear. So minus minus plus. So 3 into 3 is 9. So this is your answer. Any doubt? I'm using these two property. That means whatever be the matrix values, determinant values, their transpose matrix values also determinant values is what? Same. So another one, if you multiply the two matrices and finding the determinant, it is same as the determinant of A and determinant of B. Clear? Both are of the same order. Any doubt up to here? Clear? So then any doubt? Okay. Clear this one? So this is the concept that is being used. So look over it now. So now here A is a non-singular matrix of order 3, Clear? And A square is given as a 2A, then the values of 2A. The values of 2A. So here look over it. First thing here, what you know is that A square means what? Actually A into A. This is the first thing that you must know. Another one, if you know very well, if any constant term is multiplied with the matrix, so if you want to take constant term outside, so it should be k to the power of n determinant of A. I've already discussed this in our class. Why I am using this? Because you see here you have to find out the determinant of 2A. So first listen carefully. So first I'll put up, because here determinant is not given, so I'll write first the determinant of A square is equals to twice of determinant of A. Can we write this? Because here A square is given as a 2A. Am I clear up to here? Clear? So I am putting determinant on both sides. So now can we say that a determinant of A square is determinant of A into A? A square means what? A into A. And if you want to put 2 outside, so it will be 2 cube into determinant of A. Can we write this? Check it. Clear? So we can break this into determinant of A into determinant of A. That is equals to 2 cube is a 8 determinant of A. So from here you are getting determinant of A as a 8. Yes or no? Clear? So here you are getting determinant of A as a 8. If you have any doubt, you can ask me. I'm using just this simple property only, that A square is a into A. So again using, you know that which property I am applying over here. Again same property, determinant of A B can be breaked as a determinant of A and determinant of B. Clear? So determinant A, determinant. So this is a 2 cube is 8 into A. This is cancelled, determinant A is 8. But we are not finding determinant, we are finding determinant of 2A. So now determinant of 2A is what? It is a 2 cube. So it is a 2 cube determinant of A. So 2 cube is 8 and determinant of A is also 8. So 8 into 8 is 64. So this is the answer, a perfect answer. Clear? So I'll give you one more extra question. Suppose in this question, if they will find determinant of adjoint of A. So you know what is the properties of the determinant of adjoint of A? The adjoint of A is determinant of A to the power of n minus 1. So what is that here? This means then determinant of A to the power of 3 minus 1 is 2. So determinant of A is 8. So that answer is also 64. This I am giving you. They might ask you this also. This is the extra. Am I clear? Adjoint of A is determinant of A whole square. That is a 80 square is 64. Clear? Any doubt? The property that I have applied is this only. So can we proceed to next question? So now listen carefully. So here, this is the question from the matrices. If A equals to 0 minus tan alpha by 2 and tan alpha by 2 identity matrix, so that I plus A and 1 minus A is cos alpha and then minus sin alpha and cos alpha. So look over. Listen carefully. This can be done in many methods. Clear? I'll share you one more videos. Clear? Where I have done the same question with a different approach. So today I am applying different approach. Clear? So look up. So if you see that when you put a over here, clear? So it will be tan alpha by 2 wherever right hand side is in cos alpha by 2. So you know very well. First I will recall some class 11 formula. Okay. So you know there is a formula of cos alpha in sub multiple. There is four formula of cos alpha. One is cos square alpha by 2 minus sin square alpha by 2. Another one is 2 cos square alpha by 2 minus 1. Another one is 1 minus 2 sin square alpha by 2. And another one is a 1 minus tan square alpha by 2, 1 plus tan square alpha by 2. Clear? Similarly, these are submultiple. Clear? Submultiples angle formula from class 11. Clear? So now you can see I have shared you one more file, isn't it? That trigonometrical formula. There you can find this one. So sin alpha also we have a two formula, 2 sin alpha by 2 cos alpha by 2. Clear? So look over. And 1 minus, sorry. Another one in terms of tan is 2 tan alpha by 2, 1 minus tan square alpha, 1 plus tan square alpha by 2. This is the formula. So clear? So now if you see this question, so here is tan alpha by 2, here is tan alpha, here is cos alpha and sin alpha. So I'll convert each and everything in terms of tan alpha by 2. That means here I will write, I'll apply this formula. Cos alpha I'll use this and sin alpha I'll use this because it contains tan alpha by 2. Clear? So everyone, 5 to 8 minutes, please first concentrate over here. I'm giving a nice quick tips. Clear? So look over here. Now just tell me. Clear? Please interact it. So if this is x, clear? So what value if you put so that it will gives you 1? What value if you put in the numerator so that it will gives you 1? Tell me, what is the values? What value if x? Definitely. So here if you put x, it will be 1. Clear? Okay, now next. If it is x, clear? And what value if you put so that it will gives you y? Yes, then you have to multiply x into y so that x cancel. Am I clear? So these are quick tips. So now listen carefully. Am I clear this one? Because x is denominator. If you want 1, so I will put numerator as a x. Similarly, if you put xy, so numerator as a. If you want y, so it should be xy. Why? Because denominator x will cancel, then it will give you y. So look over. Now listen carefully. So here I am solving. Okay, LHS. So LHS is I plus a. Everyone don't write. Okay, please don't write. Please concentrate on over here. Clear? I plus a. So I plus a is, listen carefully. So for simplicity, what I'll do, I is here 1 0 0 1. Clear? Or better I'll write here. Just give me a time. So let I am assuming that for making the question simple, okay, let I'll assume that tan alpha by 2 as a x. Am I clear? I'm assuming tan alpha by 2 as a x. Clear? So then can we say that a is equals to, it is easy to look then. So minus x, here is x and here is 0. Any doubt? Clear? So that means plus, listen carefully, this is 0, this is minus x, this is min x, and this is your 0. So you are finding, when I add this one, so you are finding here 1, here minus x, here x, and here 1. This is the LHS. Any doubt? Clear? So I am just assuming tan alpha by 2 as x, so that our equation looks simple. That is only the reason. If you think that, sir, we don't assume this one, how we can assume that this tan alpha by, I will know that this alpha. So you can take tan alpha by 2 only, no problem. Then that cases you will get here tan alpha by 2, here tan, no issue. Only to make the equation look simpler, so I'm making this as a this. Clear? Assuming this as this x as a tan alpha by 2. Now RHS. In RHS, listen carefully. I minus 1 and then cos alpha minus sin alpha, then sin alpha, cos alpha. Am I clear? So what I am doing, listen carefully. So here I write, since cos alpha is what? 1 minus tan square alpha by 2, 1 plus tan square alpha by 2. And sin alpha as a what? Since you have assuming tan alpha by 2 as a t, so I am writing 1 minus t square, 1 plus t square. So similarly, what is the sin alpha? It is 2 tan alpha by 2, 1 plus tan square alpha by 2. So that is 2t by 1 plus t square. Am I clear? Clear? So I means here, I is a 1, 0, 0, 1. What is your a? So a is here 0 minus x. Sorry. Since I have assumed x, not the t, sorry, my dear. Here. So 1 minus x square, 1 plus x square. These are 2x, these are 1 plus x square. Any doubt? Since I have assumed this as a x. So 0 minus x, so this is x, this is 1. This is a bracket close. Clear? I minus a. And in place of cos alpha, clear? In place of cos alpha, I am writing 1 minus x square by 1 plus x square. Sin alpha, I am writing minus 2x by 1 plus x square. And this is called 1 plus x square. Clear? Sin alpha is there, so 2x. And this is 1 minus x square, 1 plus x square. Any doubt? So when I solve this one, everyone listen carefully. This step. So 1 minus 0 is 1. Minus minus will become plus x. 0 minus x is minus x. And 1 minus 1 is 1. So look over here, dear. Everyone listen carefully, okay? Because this last step is important. Because I will teach you now how to do smart cheating in exam. Clear? So that the examiner will not know how you have solved that one. So listen here. Up to here, any doubt? Clear? Now, any doubt up to here? Check it. Clear? Any doubt up to here? So I'm just putting the respective values only. I as this one, A as this one, cos alpha, I'm using that formula. Why I'm using this formula? I hope you understand. Because you see that our LHS part is in tan alpha by 2, whereas RHS also I'm converting into tan alpha by 2 using these two formula. Clear? Now listen carefully. Since this is a proof that, so prove that definitely LHS and the RHS is mapped. Isn't it? Both are matched. So now listen carefully. So here, better. Listen carefully. Now in down of this one. So everyone listen carefully. So look over. So this is 2 into 2. This is also 2 into 2. So you see, you know that how matrix will multiply? This into this, yes or no? So 2 into 2 into 2 into 2 is, your output is also, output matrix is also 2 into 2. Clear? So look over. This is also 2 into 2. You have to write it down for this. So everyone listen carefully. What is our right hand side proving? So you know very well. So when I multiply this into this and this into this, everyone listen carefully. So when I multiply, because you know very well, this is the first row, first column. So first row you have to multiply with first column. But you see very well, in every cases when I multiply, denominator remains same. Yes or no? Again, look over here. Isn't it? The denominator remain same. So look over here. Okay. Just give me time. Okay. I'll explain first one step in detail. Then I'll give you the shortcut. So everyone listen carefully. So when I multiply this, I'm only explaining first element, okay? This into this is 1 minus x square by 1 plus x square, plus this into this will be 2x square by 1 plus x square. These are first element. Yes or no? I hope you all know how to do multiplication. We have already discussed in the your previous class. This into this, this into this. These are what? These are second row, first row, second column. So this into this, that is minus 2x by 1 plus x square, plus x into 1 minus x square by 1 plus x square. Yes or no? So now you see that in every cases you are finding denominator same. The denominator, or every time you are getting 1 plus x square. Because why? Because each and every part over here is 1 plus x square. So you are getting a like fraction. So now listen carefully. So we will not do this long step. Why? Because even examiner will not find how we have calculated this. So listen carefully. So when I multiply this one, everywhere you are getting 1 plus x square. Here also. Here also 1 plus x square. Here also 1 plus x square. Here also 1 plus x square. Yes or no? Am I clear? Look over. Because when you take the LCM of this one, what you are getting? 1 plus x square. Then we'll get 1 minus x square, then 2x square, like this. Simplify. But it will take time. This is a detailed process. Detailed process you can easily do. Because this we are doing the PIQs. How to deal our question in exam, that I am telling you. Clear? So now listen carefully. So up to here, any doubt? Why denominator is this? So now listen carefully. I have taught you this concept. So now look over. These are LHS and the RHS. So here what is the values? Here what is the value? 1. So definitely to get 1, so when I multiply this into this and this into this, the numerator becomes same. This then only it gives you 1, because this is a proof that. So directly write this one. Even the examiner will not find that whether you have calculated or not, because when you calculate, you will definitely get this only. Check it. Check it. 1 plus x square. Clear? So in this way, even they will not deduct any marks. Listen carefully. Clear? So now listen carefully. Now here what you need? You need minus x. So if you need minus x, so I have to multiply this with minus x, 1 plus x square, write down. Why? Because this denominator, it is the concept of this one. What value if you multiply, so that you will get y? So that concept I am applying over here. So what value if you multiply, you will get minus x. So denominator should be there so that I can cancel. Second, here you need x. So I will write this as a x, 1 plus x square. And here you need 1. So here I will write 1 plus x square. Actually, when I multiply this into this, and so one more steps, so it is same, but don't waste your time. Be smart. So this and this cancel. This and this cancel. Because this is a proof that obviously LHS and RHS will match. So minus x, x and 1. So this is equals to. Am I clear? How to deal? So therefore, LHS is equals to RHS proved. If you have any doubt, you can ask me, because this is the best way to solve this question. But make sure that clear. So this one should be in this way. So because when I multiply everything, the denominator remains same. First I have written the denominator. Then why this value is 1 plus x is how? This is a quick tricks actually. There is actually when we multiply, there is a, if you need a detailed process, you solve this one. So here you are getting same. So here also if you solve, look over. What will be the cases? What is the LCM? What is the what is the cases here? 1 plus x square over here. So you are getting minus 2x plus x into 1 minus x square. Check it. So if we take common, so yeah, minus x common, so it will be 2. It will be minus 1 minus x square. Take it. 1 plus x square. Clear? When you take a minus common, so it is a 2. This is a minus of this. So minus x as it is. So 2 minus 1 minus plus x square divided by 1 plus x square. So numerator denominator same, isn't it? Minus x, you are getting 1 plus x square. So you are ultimately getting same only, because this is a proof that, you see, I am written same only. Minus x 1 plus x square. Even the examiner won't understand that whether you have solved or not. Maybe they understand that you will solve in the rough, but this is the way to how to solve the question. This is very important part. Any doubt? So this is very important question. Remember that. Clear? So I'll share you one more video. So where I have converted this to basic identities, sine alpha by 2 cos alpha by 2. So but I think the best method is this method. A best method is this one. Clear? So that's all for today class. Thank you so much and have a great day.